So now we look at the other derivative, which is we're going to look at the variations with respect to the humidity when the temperature is fixed, which is we're going to fix the temperature at 96 degrees. So we look at this, the red row in terms of variation of the humidity. So all this in red row, we assume the temperature is fixed at 96 degrees. So we do the same thing. Well, the variation of humidity either change by 5%. So if it rises 5%, we can see the heat index is 130. So we look at this, right? We're going to look at this fixed temperature at the 96 degree and look at the variations of humidity. All right. So we go up to 90 because the only information we have is at the 75%. So the index is 130. So and the answer is 1. And then now down on 65%, we can see the heat index is 121. So 121 minus 125. So we going down, so it's divided by -5. So the variation is 0.8. So on average, the variations around humidity is 70% is 0.9, which it says when the humidity is 70%, the heat index rises about 0.9 degree for every percent of the relative humidity rises. So in general, as you can see, when we check the variations on the two variable, we always fix one variable and look at how the other one changes. So if f is a function of two variables, x and y, and suppose that we let only x vary, then meaning we let y to be fixed, just give it a constant at some point. We pick a constant, and then we look at how x changed when the y equal to that particular constant. So meaning, if we're going to look at we really consider function as a single variable of x. So g of x, we're just simply plugging y to be b. So now we just only have one single variable, and we look at the derivative of that. We'll call that partial derivative of that with respect to x. So we look at the partial derivative with respect to x at ab, then we'll first fix b first, plug in y equals b. We'll then take a derivative and then evaluate at the point A. So we can say this, right? So the little x meaning the partial derivative with respect to x, which is the first variable, at AB, meaning is a g as a single variable, the derivative of g at A. And what's the function of g? Function of g is simply evaluate the two variable function, you plug in b as a constant, now you turn out to be only one variable x. So let's look at this example right here. Okay, for example, f of xy equals x squared times y minus 3y to the fourth. We want to find the partial derivative of f with respect to x at the point 1, 2. So what do we do first, before we take a derivative, we want to turn it into a single variable. So we evaluate y to be 2. We plug in y to be 2, so you have 2x squared, y is a 2, this is your y, and 2 to the fourth power, which is y to the fourth, 2 to the fourth, which is 2 to the 4, which is 16. 3 times 16, you get 48. And that's a single variable. Then we take a derivative of that function, which is what? Derivative of 2x squared, you get 4x. Then we evaluate the point at 1. You plug in x to be 1, so the answer is 4. Well, since we're treating the second variable, the y, as a constant, so instead of going through this long process, we can do it all at one time. So this is what we're going to do. We can do the following way. We go ahead, take the derivative of xy with respect to x, treating y as a constant. So you go by the function f of x equals to x squared y minus 3y to the fourth. If we take derivative with respect to x, so x squared derivative of x was 2xy, because we're treating y as a constant, therefore derivative of a constant equal to 0, so it's gone. So now your answer is 2xy right here. All right, 2xy, now we want to evaluate this point at 1, 2. So we replace x by 1, y by 2. And the answer is still 4. These two are equal. So I will recommend the second way. It's a better way to do it. So eventually, this is what we do. But the definition of a derivative, we have this, right? Derivative of a function a is little variation of a at the function value divided by minus the function value at a and divided by the variation of h, which is very small. So follow that, the partial derivative of a at the point x is the same thing as you now plug in the value of b, all right, now vary just the first coordinate just a little bit. So that is what we do here in the front.